So I'm Sean, you've already at this point gone through several of these. Lab is going through the Fenlon's equations. The basic concept is we take an object, it's an arrow here, it could be a pencil, it could be anything, it doesn't really matter. And it goes through a lens and focuses out on another point. We can trace these out through specific lines in the lens that have been documented here. The specific property of these is lenses have a focal point. Technically it's twice the radius, but all you need to know is that the lens has a focal point. And rays will in some way transfer through them, in this case down and out. You guys don't fully need to know that aspect, but it is what's going on. So if you trace all the light rays, and there's ones in between, they'll all focus to this other spot. There's two properties we can measure. This is a physical object. This just looks like one, like how when you look in a mirror, you think you see yourself. Or in this case, it focuses. Depends what kind of lens we have. But we have the object's height, and we have the image height. These two will be different. When it's upside down like this, that's negative, because if we measure from your feet up, that's positive. Going down, it's negative. That's how we determine that. The other big variables is the object distance, which is measured from the actual object to the center of the mirror, and the image distance, which is measured center of the mirror to where that's focusing. It's dictated by this equation. The lab's kind of weird. It expects you to find this equation and simultaneously use it. Don't worry about that right now. But we're going to use this, and at various points we're going to change this object distance and then measure where this image is actually focused. You'll actually see light on the other side in other positions, but it's not focused. So you find the two distances, and we're going to ultimately find this focal length. First you make a plot just of the two variables against each other. Then your procedure tells you to plot 1 over each variable as their own, like this. So your x becomes 1 over your object distance. It makes this whole equation have the exact same form. It's a linear one, and this intercept will give you what your focal length is. Shown that there. It's pretty straightforward, but going through the data will make this more clear.